In this video, we'll discuss about Vedic math divisions and common link between amongst the divisions. Okay, it's video number 11. It's part 1 of 4. I divided that video in 4 parts, and this is the first part. In this part, we would look at the common links amongst various division methods. Okay, let's continue. It's video number 11, part 1 of 4. Let's continue. Let's look at outline here. We first section is about common link amongst division methods. Trying to compare the division methods we have used and we would use, and trying to find a common link. Okay, let's find out. That's next. Then we have section on division using 2-digit divisors. Next we have a section on 3-digit divisors. Division when divisor is 3-digit long. Let's continue. And after that, we have a consider a divisions where number of digits in divisor are 4, at least 4, and maybe cap what we have so far done in divisions. Let's continue. Okay. In nickel method of division, which is given by this in this video, we argued that nickel method emulated straight division. Let's continue. We assume that transpose and apply method of division also emulated straight division. So straight division was emulated using these methods also. And now we will come back to the straight. To recap, in transpose and apply method division, we related two methods. First, by stating transpose of surplus was effectively a deficiency. So the two methods discussed previously, Nicola method and transpose and apply, and we declared over there that transpose of surplus used in transpose and apply method was effectively the deficiency which was used in Nicola method division. So these two were related already. Okay? And connecting links are, one is base numbers, proportional base numbers, and proportionality can be 1 or higher. Let's continue. And two-step division. See, divide first by natural base number. Two-step division is, first division is by the natural base number and second division is by the proportionality. So we first divide by the natural base number. Okay. Let's continue. Then divide second by the proportion, which may be 1, and adjust for deviation. Deviation is a common term I'm using both. You will notice that same links connect straight division method to previously discussed method. Say, we use the same concept of two-step division. Divide first by natural base number, then by proportionality, and make adjustments. Okay. So same links applied in the previously discussed method. Let's continue here. And in fact, straight method of division covers both the previously discussed methods, which were Nicola method of division and also transpose and apply method of division. In Nicola method of division, we also discussed how to compute recurring numbers using Nicola method of division. So, and same method applies, the same mechanism applies to computing recurring numbers. Let's continue here. Had we not ventured into proportional based numbers, straight division would have been an entirely new method. However, we explored proportional based numbers in previous division methods, and we would find that the methods are functionally equivalent. We'll find when we go into straight division method that the straight division method is functionally equivalent to the base division methods. Issues encountered. Let's recap the issues we had. In nickel method, we were adding adjustments. Sometimes we got a multiple digits in quotient or in adjustment positions. And how do we work around those issues? We usually look look ahead and anticipate a carry to mitigate the issue. That's the way we would use. This is the mechanism. Look ahead mechanism is the one we used to mitigate the issue of multiple digits in a quotient position or in a adjustment positions. Let's continue here. In transpose and apply, we have to contend with both large positive numbers and large negative numbers. In computing 1 over 3, we encountered both the large positive and large negative numbers. And how did we work around those? We used negative digits and altered remainders to mitigate the issues. Okay? So when we got into the dividing 1 by 13, we had in quotients we had 1, next quotient value was -3, next +9, next -27, next +81, and so on. And in that case we use the negative digits and also altered remainder methods to mitigate the issue. Then the issue was manageable after we used issues encountered. Again, continue. In dividing 98765 by 89, when we use a base number of 100, we were getting a larger numbers in quotient and also the uh, in the adjustment positions. So, but we use the proportional base number to mitigate the issue. Instead of using 100 as a base, we used 90 as a base, which was 9 times 10. Let's continue. When we get into the issue in straight division, we will use look ahead, all these mechanisms we learned so far, altered remainders, negative number to reduce. Let's continue. We'll use a comparative example. Tirthaji uses this example here, 38982 divided by 73, to illustrate that previous methods are cumbersome and straight method of division eliminates the issues. Okay, and let's see, Tirthaji shows that these two methods are different, and we would try to show that these are functionally equivalent. Okay? Let's continue here. We will show that methods are similar, and in fact these are functionally equivalent. Let's continue here. Transpose and apply method, we will use it. Divisor is 73, which is proportional base number is 70, surplus is 3. Okay? A two-step division is 10 times 7, and transpose is -3. So we will first divide by 10, then by 7, and we would adjust for the transpose, which is -3, when there is a non-zero quotient digit. Let's first do a transpose and apply method. Divisor is 73. This repeat here. Proportional base number is 70. Surplus is 3. Two-step division is 10 times 7. First divide by natural base number 10, then by the proportionality, and transpose is -3. Transpose of surplus is -3. Let's continue here. So we set up the problem like that. Divisor 73, transpose -3, and dividend is 38982. Okay, let's continue. First we divide by 10, first division. Okay, we just did. Let's continue. Then next we divide by second division. 38 divided by 7 is 5, remainder 3. Okay, so we got 5, remainder 3. Now in next column we have 39 and plus adjustment because of this quotient 5 and surplus -3. Let's continue here. Adjustment in the next column due to transpose are 5 times -3, which is -15. Okay, so -15, 39 -15 is okay. And 3 times 10, and total adjustment is 3 times 10 for 3 from the remainder, which is proportional, -15 from this one here, which is equal to 15. Okay, and working dividend in that column would be 9 plus the adjustment 15, which is 24. Continue. Dividing by 7 in that column we have 24 divided by 7 is 3, remainder 3. Let's continue. So we got 3 here and the remainder 3. Okay, Okay, let's go next column. Now working dividend in next column is 38 minus 3 times 3, 29. 38 minus 9 is 29, and 20 divided in that column, 29 divided by 7 is 4, remainder 1. Let's continue here. 4 remainder 1. Let's continue. So next remainder is 12, the gross remainder, and plus the adjustment 4 times minus 3, which is 0. So remainder is 0. Let's continue. Okay. That means 38982 divided by 73 is 534. Remainder. Let's continue with our comparative example. Okay, now we do straight division method. So we have divisor is 73, where we say 3 is on the flag. That's what we say. eh, We use the left digit for division, and 3 we put it away for a while, put that on a flag. Let's continue. So how are we going to do that? Okay. So first this setup problem here, 38982 is the dividend and 73 is the divisor. Okay, let's continue. So what we are doing, Tirtha just suggests that drawing a line to the left of the rightmost digit and move the rightmost digit on the of the divisor on the flag. So move the 3 on the flag and draw a line to the left of the 2 on in a dividend. Let's continue. Effectively, what is the divide both the dividend and divisor by 10. So we are going to do that. We just we divide the dividend and divisor both by 10. Okay, let's continue here and also move this 3 on the flag. Let's continue here. Entire division is by 7. Okay, we have set aside one column to the right for remainder, and there is one digit on the flag. So set aside this column is for remainder here. We got one digit on the flag. Let's continue with this is what we had before. Now we are going to divide by 7. 38 is my dividend I'm going to use to divide. 38 by 7 to get 5 in the quotient position and 3 as remainder. Okay, let's see what we do. We have a 38 divided by 7 is 5, remainder 3. Let's see what we do. So we got a 5 here in the quotient and a 3 as a remainder. Okay, let's continue here. From 39 we deduct Q, which is 5, times flag, which is 3, and which is 15. So that means that effective dividend in that position is 39 minus 15, which is 24. Let's continue. Dividing in that position, we have 24 divided by 7 is 3, remainder 3. Let's continue here. So we got 3, remainder 3. Okay, in next column now. In next column, effective dividend in next column is 38. That's that one here, minus 3 times 3, minus 9. So which is 29. Okay, let's continue here. Dividing in that position, in this position here, which we have 29 divided by 7 is 4, remainder 1. Let's continue here. So we got 4, remainder 1. Let's continue. Now we are in effective remainder is 12. 12 was the gross remainder, minus 4 times 3. 4 the quotient digit and 3 the flag digit. Let's continue here. Yeah, so we got a so that means that 38982 divided by 73 is 534, remainder 0. Let's do some observations here now. In my humble opinion, two methods are functionally equivalent. Difference is not what, it's instead when. Now the differences are, in the base division we transpose surplus on setup. So we computed transpose of the surplus when we set up the problem. Okay? In state division we add negative of Q times flag, which is the two end up being equivalent. We compute adjustments as soon as we can in the base divisions. As soon as we know a Q digit, we compute the adjustments. Okay, and we compute adjustments when needed in state division. In state division, we would use the adjustments when we need them. Okay. Let's see why there are different approaches. Let's continue here. Tirtha shows division without dividing in base divisions. When Tirtha is doing base division, he's trying to show that it's possible to divide without really dividing. Okay? So as such, he stays with the natural base numbers only. Okay? And I have concentrated on, let's see what I have been trying to do, exposing underlying math. I'm trying to discover what's the underlying math is. Okay, continue. And exposing common link amongst all VM method division methods. And there is a common link, and I want to expose that. Let's continue here. And Tirthaji is comfortable with the dry line to the left of so many digits for remainder. Okay? To me, that let's see. To me, that appears to be hiding something. I'm more at home with the dividing by corresponding base number instead of I end up drawing a line, but I do that with the full knowledge of that I'm dividing by a base number. Let's continue here. We had used proportional base numbers in base multiplications, and we should use the same in base division too. But VM community is comfortable using only the natural base numbers in base division. Tirthaji used only the natural base numbers, and VM community is comfortable using only the natural base numbers. Okay, now question is, do we need straight division? Yes, you sure do. Not that fast. Tirthaji devoted a whole chapter. Okay, straight division uses vertical and crosswise for multiplication and is suitable for mental manipulation. Okay. I know that we didn't see a vertical and crosswise here because we were multiplying single digits. When we go to multiple digits, then we get to see the magic of vertical and crosswise. Okay, so it's a suitable for mental manipulation. We use this method in okay, computing square roots, computing cube roots, and we do not plan to cover that. Okay, I don't expect to have a video on computing cube roots. Let's continue here. Computing real solutions of a quadratic. Quadratic can have a complex solutions, also can have real solutions. Okay, we can use this method to compute real solutions. Okay, I need to look into it later. Maybe we can use the same method in computing complex roots also. Okay, of the. Let's continue here. This is one of the references, Teacher's Manual 1 by Ken Williams. It's available in a PDF form from the free in a PDF form from vedicmaths.org. Let's continue. Tirthaji's book is the reference, and that's what I used in this video. Let's continue here, and there's a good reference books for Glover's books are 3 books, okay? And Vanna Singhal's book is a decent book for most of the topics. I don't recall if straight division is covered in Vanna's book.